Put the software in the public domain, somebody else would be able to make a little bit of changes and turn that into a proprietary software package, which means that the users would be running our software, but they wouldn't have freedom to cooperate and share. To prevent that, we use a technique called copyleft. The idea of copyleft is that it's copyright flipped over. And what we do is we say, this software is copyrighted, and we, the authors, give you permission to redistribute copies. So we give you permission to change it. We give you permission to add to it. But when you redistribute it, it has to be under these terms, no more and no less. So that whoever gets it from you also gets the freedom to cooperate with other people if he wants to. And then in this way, everywhere the software goes, the freedom goes too. And it becomes an inalienable right to cooperate with other people and form a community.
And so what is that, the license, what does that go?
Well, copyleft being a general idea, in order to use it, you have to have a specific example. And the specific example we use for most GNU software packages is the GNU General Public License, particular document in legalese which accomplishes this job. A lot of other people use that same license. For example, Linus Torvalds uses that license for Linux as well.
Well, the license I use is the GNU General Public License. That's the one that Richard Stallman wrote, and I think it's a really astounding contribution. It's one of the few software licenses that was written from the standpoint of the community rather than from the standpoint of protecting a company or, as is the case with the MIT and the BSD license, performing the goals of a government grant program. And the GPL is really unique in that it's not just a license, it's a whole philosophy that I think motivated the open source definition. I don't hide that a lot of what I do came from Stallman.
A crucial step in the growth of GNU, Linux, and the free software movement was the creation of businesses based upon the software and philosophy. Ground zero for the beginning of the business phase was the Electronics Research Lab at Stanford University. Known as ERL, the lab was the place where the first GNU and Linux businesses found their inspiration.
So right here is where ERL was. That would have been the entrance over there next to the Electrical Engineering McCullough building. If you walk in, you come in, you walk down the hallway down here. My office would have been about here. And then right across the hall from that was Michael Tiemann's office.
Michael Tiemann took and started a company, Cygnus Software, but the idea was to sell consulting and services around the GNU free software. And, well, Michael's done very well with Cygnus.
Well, I spent a lot of time working out how we were going to make money, and in the original GNU Manifesto, which is the last chapter of the GNU Emacs manual, Stallman proposed a number of different possible ways to make money.
From the beginning of the free software movement, I've had the idea that there's room in it for business to be done. One of the advantages of free software is that there's a free market for any kind of service or support. So if you are using software in your business and you want good support, you have a choice of people to go to for it. You have a choice of businesses that are in the business of providing you with support. So they're going to have to, in general, give you good support or you'll go to somebody else. With proprietary software, support is a monopoly. There's one company, typically, that has the source code, and only they can give you support. So typically, you're at the mercy of a monopoly. That's the case, for example, with Microsoft. So no wonder the support is so bad.
The benefits of free software were tremendous, but the cost of supporting it internally made managers very, very nervous. And so the fundamental idea I had was if we could build a model that could deliver 2 to 4 times the support and hand-holding capability that an internal engineer could provide, and we could do it at 1/2 to 1/4 of the cost, that would meet the test of whether or not people would actually buy. And by about the fall of that year, we had all of the things worked out about who we needed on the technical team, what the terms of the sale would be, what the key price points were, and we actually received our incorporation in November of 1989. One of the most difficult things in starting our company was actually finding a name for it. I explained this to one of my friends. We were having difficulty, and he returned an email message that basically just had a bunch of words with the name GNU in it. And Cygnus was the one that looked least obnoxious and least obscene.
I can say very clearly that Cygnus was the first business that specialized in free software. Cygnus supported free software, filled a very essential niche because we had this great software, you could get it for nothing, but you couldn't get support, and they made their money by charging for support.
The GNU project started by building a toolkit of basic development tools such as a C compiler, a debugger, a text editor, and other necessary apparatus. And their intention was eventually to develop a kernel to sit underneath those and be the center of the operating system. By about 1990, they had successfully developed that toolkit, and it was in wide use on a great many variants of Unix, but there was still no free kernel.
The kernel happened to be one of the last things we started to do, and we had started it not long before. And that's when Linus Torvalds came along.
Linus or Linus? What's your preferred pronunciation?
When I speak Swedish, it's Linus. When I speak Finnish, it's Linus. When I speak English, it's Linus. And I really don't care how people pronounce my name. But Linux is always Linux.
He developed a kernel and got it working faster than we got ours working, and got it to work very nicely and solidly. His kernel is called Linux.
The initial goal was my very personal goal, to be able to run a similar environment on my computer that I had grown used to at the university computers. And I could not find anything that suited me for that. Right? So having been doing computers for all my life, basically, at that point I just decided that I'll do my own. Most of the inspiration early on came from Sun OS, which was what I was using at the university at the time.
Which university?
University of Helsinki, Finland.
From 1991 to about 1993 was really, I guess, the infancy period of Linux. That was when it was still only alpha or beta quality. It was relatively unstable, although even then it was a good deal more stable than a lot of what are now called production operating systems.
Linus used the traditional tried and true method of writing one program that does the job, and he got it to work quickly, in fact, faster than I would have thought was possible.
The term for it is monolithic, which means that basically the OS itself is one entity, indivisible, while in a microkernel, the operating system kernel is actually just a collection of servers that do different things, and then they have a common protocol for doing communication between themselves.
So why is it that if the GNU project had so much lead time, so to speak, doing this, why is it that he was able to kind of come in at the tail end,
well,
so to speak?
We actually started the GNU herd not long before he started Linux. And as it happened, though, we chose a design that's a very advanced design in terms of the power it gives you, but also turns out to be very hard to debug. We decided to divide up the kernel, which traditionally had been one program, to divide it up into a lot of smaller programs that would send messages to each other asynchronously to communicate. The problem is that that style of programming has a great deal of potential for bugs, which are often very hard to figure out because they depend on, does this program send this message before or after this one sends that message? And the result was, it took us years to get the thing to work.